Okay, so this morning the last piece arrived, the Bondtech BMG, and I was able to finish the assembly of the new printer, the C3Dt DZ for double Z axes. Some of you might look at this and say, well, this looks familiar, and it's correct. This is a derivation or a further build upon the earlier C3Dt/C, the cantilever printer. So the cantilever printer basically was missing this whole component here, but beyond that, instead of going with a full frame, a few other changes were made. I'm running a 32-bit SKR board with TMC 2209 chips. Furthermore, let's see, the other differences, well, actually the same things are, I'm again using the Biltech flex plate and the Bondtech extruder. This one has my new parts cooling fan that actually is tacked onto the Bondtech extruder, but you can actually disassemble and remove the fan without actually having to remove the Bondtech extruder. So in this video, the only thing I'm going to do is I just finished assembling it, so we're going to test the main features to see everything is working and configured properly. So we'll be looking at the, first of all, on and off and see nothing smokes, LCD screen. We're going to test the end stops. We'll test the motion carefully to see if they're moving in the correct direction or if I have to go back into the firmware and put some of the inverts on. It has a Kinovo heater on here, 24 volt, 300 watt, which is kind of heavy for this printer. It's going to take up a lot of power of the actual 15 amp power source, because 24 300 watt is close to already 12 amps, more than that, but of course it's not going to be running. See if the hot end works, and know if all the thermistors are working. And we're going to run the extrusion to see if the actual motor runs and if it runs in the right direction. And then we'll test if the parts cooling fan. So that's really the only thing we're going to do in this video, is test the basic features. If everything works, and by the end of this, if no smoke comes out of the printer, then we're in good shape. All right, so first things first, this is an enclosed power source. There's an on and off button behind here that turns on the printer itself. Now the first thing I see is the heatsink fan kicked in. Now the interesting thing about the heatsink fan is this is a Noctua fan, but because the power source is 24 volts, you cannot get a 24 volt Noctua fan. So I got a 5 volt Noctua fan. I'm actually running it off of one of the end stop, the Z Max, I believe, power source, which is also on the SKR 1.3. That's a 5 volt output, and I'm hoping that will provide enough power to cool the heatsink. So that's working. The LCD came up properly. First glance, the thermistors, we've got 20 degrees on the hot end and 21 degrees on the bed. They, technically speaking, should be the same since we haven't turned anything on yet, but close enough, I guess. The custom name, C3Dt DZ 0.1 version, so that every time I do like a little update or a change to the firmware, I can put the version a little bit higher to make sure that I've got the latest version running. Okay, so in order to test all of this, I am going to use Pronterface. So I am going to connect one of the features I did in this printer. So the SKR board, I have the USB port exposed to the front, but I also have the micro SD card exposed. So it is very easy for me to update the firmware and basically just copy it onto the SD drive and plug it back in. There's another mechanism to do it on the board where you have to flip the USB jumper back and forth, that I wasn't really a big fan of. So what you can do is you can just basically copy the latest firmware.bin on top of the drive next to the .cur drive, and that will, when you turn it on, automatically update the firmware. So we're going to plug in the printer. Okay, and what pops up is the actual drive, so you can copy stuff directly to the drive here. You don't even have to take it out, which is nice. Okay, so then I'm going to, let me add Pronterface to the screen here. So here we have Pronterface in the video. I am going to connect, and it will be most likely on COM5. Baud rate is at 250,000. I'm going to connect, and it says it does not like the baud rate. So let's see. 11.5200. Now this is interesting. It's complaining about the baud rate being incompatible. And that actually is a new one to me. Oddly enough, it is not unless it's just not the right COM port. Couldn't be COM1, could it? Oh! So here's something interesting. It is just simply not connecting. Let me close Pronterface and open it up again. Maybe. Oop. Come on, Pronterface. There you are. Oh, so what happened was I had Pronterface running, and so it did not pop up the right port. So let's set it back to the highest baud rate again, and it's COM8, and let's connect. And printer is now online. Let me run a M503, which should dump all the information I have so far. Nothing out of the ordinary here. Acceleration, let's see, steps per millimeter, that seems about right from what I configured. I am going to also going to run a M122, which should give me the information about the stepper drivers, and right now I am getting values here that are not FFF, so it looks like it connected to all the 4 stepper drivers. So I'm using TMC2209 on all 4, so XYZ, and the extruder. Now I've got the current set at 840 right now, which we might crank up because I think these motors are a bit, well, actually the Z motors, yeah, we might crank that up, but we'll leave it as is for now. But that connects fine too. So the next thing I want to test is the end stops, to make sure that the end stops are working. So I'm going to send an M119, and currently nothing should be triggered. And as we can see, let me resize this a little bit. Of course, doesn't get much bigger, the text here. Okay, so open, open, open. So what I'm simply going to do is I am going to press in one of my end stops, and that one is the X, and it shows as triggered when it's pushed in. I am going to do the same thing on the Y axis, and I'm going to again send M119. That one triggers fine too, so that's a good thing. The next thing I'll need to test is the Z end stop, which is actually a proximity sensor that we're running here. So the first thing I'm going to do is I'm just going to add some metal, and what I can already see is the light is coming on, so the sensor itself is working. Now we just got to verify that the signal is coming through to the board, and Z equals triggered. So I verified that all the end stops are working, the drivers are up and running. So what I am going to do next is I'm going to test the motion, and I'm going to just do little steps to make sure that I actually do have motion, that the motors are running first of all, and secondly that they're going into the right direction. So I'm going to, the first thing I'll test is the x-axis, and I'm going to just press the 0.1 millimeter, which should just give a little tick, and that moved. And when I move to the right, the axis moves to the right as well. So let me do 10 millimeters and 10 millimeters back. Alright, so that runs. The x-axis is functional. I'm going to do the same thing with the z-axis, which is, sorry, the y-axis, which is the bed. And I'm going to do a small step. Alright, I hear something. Let's move it. Alright, that moved. So that moves fine. So when I say y plus, it means that the bed should be moving forward, and y minus, bed should move back. Now, one of the things I do notice when I run the motor, I get a singing noise as an after effect on the motor, which is something that probably, if I change the current, will go away. But I've got movement for now, so that's all that I'm looking for. The z-axis, so I have two motors running parallel off of the z-axis, so I didn't do the dual motor thing for this setup. I'm not even sure if I ever want to go there, but for this one it's basically two z motors running parallel off of the z stepper motor. So I'm going to move up 1 millimeter, and that seems to be running fine. I'm going to try 10 millimeters, and when I go up, the z-axis goes up, so that's working too. Let's go down. Okay, so that works properly. So the next thing I can do is, well, I'm gonna, yeah, actually let's just go for it. I'm gonna try a home. So I'm going to do a G28 and see what happens. So what should happen, because I have the Z-safe homing on, it should go X and Y first, and then once those are homed, the extruder should go to the middle of the bed, and then it should probe the Z-axis. So let's run G28. Alright, so there goes X. That worked. Z. That worked. And it's going to the center of the bed. That works too. And it's going to try to probe. And I actually am going to hold my finger on the off button because I do not want to destroy my build tech. Nope, that is good. It had a good clearance between. Excellent. So that all works. The next thing I am going to test is I'm going to see if the bed heats up. So I'm going to set the bed to 70 degrees. And again, this is a Kinovo silicon heater underneath here. Originally the bed had a heating element inside of it, but it was a 12 volt. So I was left with the option of either, because I have no room for like any stepping down of the voltage, so I could have done the PWM to 0.25 maximum, or basically a quarter of the maximum PWM, which would have kind of mimicked the 24 volt, but there's some risk associated with that, so I actually ended up getting a customized Kinovo bed for exactly 24 volt. So that should run fine. So I'm going to set that to 70 degrees, and if we look at the LCD, I see the 70 degrees. Temperature is going up. One thing I will have to figure out is that because this is using the Kinovo, and then it has the aluminum bed, on top of that it has the Buildtech flex plate system, and then the bed. So 70 degrees at the bottom does not necessarily mean 70 degrees on the top, because the actual thermistor is part of the Kinovo bed. So I'm going to have to figure out going forward when I start printing is like, what is the actual difference between the bottom and the top of the bed, and what, or at least what the delay is of, like, when this turns 70 degrees at the bottom, how long does it take before it gets 70 degrees at the top. As for now though, it looks like it's moving up nicely, so a little jumpy, but let's see. This is where it slows down a little bit. I also need to do PID tuning, but I'll do that once everything is tested and up and running. Right now I'm not even sure what I set in the PID tuning. Whatever is default, I think, in the Marlin firmware. Now it's approaching 70 and I can hear some of the MOSFET clicking in there. Don't know if that is healthy, but that's, you know, you can kind of hear it. So it's slowing down the heating. And that's not too bad. I think that was not much more than a minute. I'll have to do the time later. The bed right now feels warm at the touch. Not, yeah, well, it's getting pretty hot. Okay, so that's good. The bed heats up nicely. Let's try the same thing on the hot end. I'm going to turn the heat up on the hot end, and I'll set it to, let's set it to 210 for PLA. And at this point, I think the most interesting thing is going to be the actual power usage, because I think with both the bed heating as well as the hot end, I might be reaching the limits of this power unit. And worst case scenario, this is a 15 amp 24 volt PSU. I might have to go to a, I believe there's a 40 amp universal available that's the same size as this one. Should this just not provide for enough power, but let's see how this runs. Okay, temperature is moving up nicely for the hot end as well, so clearly that is working. This, by the way, uses a 24 volt 40 watt heat cartridge, so it's a little bit more power than the standard one that you get when you buy your C3D hot end. But that seems to be going up pretty nicely as well, so that seems to be working. Now while it is heating, I think I can test the parts cooling fan. So let me just turn on the parts cooling fan with M106. Let's do S200, and that works too very nicely. Let's go to 250, 254. So that's the max speed for the parts cooling fan. So that works nice. So at this point, the only thing left to test is the, so we're getting up to 210, 27, 208, 209. So at this point, I should also be able to extrude. And right now, the only thing I'm going to be testing is to see if I'm actually getting motion. So I'm going to extrude 50 millimeters. And press extrude. So I see it running, and it looks like it is turning in the proper direction. It's turning clockwise, which means that whatever filament goes through here will be pushed downwards. So extrusion works. So there you have it. The new C3Dt DZ looks like it's operational. So that's awesome. The next steps that I'll be doing is I'll be calibrating the bed itself to make sure that the Z offset is properly set. And then the next video you can look forward to is hopefully the very first print with the C3Dt DZ. So if you like this, click the like button, subscribe if you want to see more of these videos. This printer can be seen first in a couple of weeks at the Elkhorn Mini Maker Faire. Of course, I will be present at the Midwest RepRap Festival in March this year. I will have this printer along with the C3Dt cantilever, and of course along with the Big Delta as usual. So if I see you there, stop by, have a look. and I'm wrapping up right now the instructable for this printer, so you will be able to build this printer step by step yourself with the instructions available and the links to all the products. I want to give a shout out to Bondtech and to Buildtech. They both assisted me with this printer. Considering I don't really sell anything and I have to do this out of my own budget, that really is a big help. So see you in my next video, where I'll be printing the first piece on the C3Dt DZ.